From our offices here in Northern California, the specialists at Max have worked for over 25 years to develop the engineering and manufacturing technologies to handle the most difficult liquid flow measurement applications for our customers. Max has found that many customers have trouble accurately measuring flow rate applications which have wide flow ranges, low flow rates, or precisely measuring high and sometimes changing viscosity liquids. To solve these problems, Max has developed some very specialized tools, the Max line of positive displacement flow meters. Positive displacement separates a flowing stream into discrete portions of known volume and counts them as they pass through the meter. The volumetric displacement of a positive displacement flow meter is firmly fixed by its physical dimensions. The amount of liquid which passes through with each revolution doesn't change. It's exactly the same each time. It's kind of analogous to filling and emptying a precision flask of known volume. Positive displacement flow meters utilize a mechanical motion and the fit of machined parts to form their measuring chambers. It is direct, non-inferential, and is not affected by the fluid's viscosity, density, temperature, pressure, or turbulence in the flow stream. The measuring chambers shown here are progressive cavities formed by two helical screws. Other Max meters use piston cylinders or pockets between gear teeth. In each case, the chamber volume is fixed. This produces a high level of repeatability and eliminates drift in the output signal. These characteristics are common to all positive displacement meters. However, Max has differentiated itself by optimizing the flow meter designs and manufacturing processes needed to specialize in the difficult applications of measuring wide flow ranges, low flow rates, and viscous liquids. What allows a Max flow meter to handle these conditions when other flow meters can't? First, understand that the volumetric efficiency of the chamber and the repeatability of the mechanics behind its formation are key factors in bringing positive displacement theory to the real world of process measurement. Let me demonstrate. Here, Max has optimized the fit between the pistons and the flow meter body. The fit between mating parts is very precise, significantly reducing the amount bypassing the measurement chamber, referred to as blow-by. Max piston flow meters have a nominal clearance of 2 to 3 ten-thousandths of an inch between the displacement piston and the measurement cylinder. This results in a high volumetric efficiency, as the blow-by is minuscule compared to the amount measured by displacement. So, even when you're running at 1/1000th of full flow capacity for the piston flow meters, a Max meter will maintain its linearity to within 0.5% of the actual flow rate. In addition to the precision fit, Max has reduced the flow meter rotational friction, lowering the pressure drop across the measurement chambers to an absolute minimum. Likewise, Max's use of a patented ball bearing supported mechanism and the elimination of all wiping seals or piston rings enables the flow meters to turn smoothly and easily down to 1 RPM. Again, these refinements are primarily responsible for extending the Max flow meter's accurate measurement range far beyond that available from any other flow meter manufacturer. To help visualize the extended RPM capabilities of a Max meter, imagine using a meter rated for 350 gallons per minute to measure a 3-gallon per minute flow, or using a meter rated for 1500 cc's per minute to measure a flow rate of less than 1 cc per minute. All Max flow meters possess these extended range capabilities. To measure the lowest flow rates possible, Max has designed a flow meter with a displacement of only 0.87 cc's per revolution. Cutting the liquid stream into very small pieces. The meter's resulting high resolution and low flow rate capability allow it to differentiate between zero flow and an extremely low flow rate, as well as detect the abrupt changes and near zero flow rates of an intermittent or on-off flow stream. Changing viscosity or high viscosity fluids pose another measurement challenge. In an attempt to maintain a low pressure drop in the process, the engineer may need to increase the size of the flow meter, lowering the RPM of the meter. This would cause any other brand of meter to stall. However, a Max flow meter with its wide operating range will continue to provide an accurate, repeatable output down to 1 RPM. Meter sizing is available for all viscosities, and the low RPM associated with high viscosity is not a limitation. If the fluid can be pumped, Max can measure its flow. If the liquid viscosity varies, it will still displace the same volume as it flows through the meter. Combining these two attributes makes Max unique in its ability to measure liquids with viscosity as low as 1 centipoise and beyond 1 million centipoise with the same flow meter. To illustrate my point, here's an example of a process requiring precise flow measurement with varying viscosities, intermittent flow streams, and a wide range of flow rates, altogether presenting a formidable measurement challenge. This process depends on Max meters for accurate and repeatable measurement of each component stream. Our meters ensure the quality and consistency of the final product day after day. When you need to measure flow rates as low as 1 cc per minute, call Max. When accuracy within 0.5% of reading over a 100-to-1 flow range or larger is required, call Max. If your fluid's viscosity is high or changing, or if intermittent flow is a problem, call Max. Max meters are specialized tools, and the applications that require a Max meter are usually beyond the capability of any other brand of meter. Don't let the limitations of other flow meters convince you that your flow measurement answer is unattainable. Only Max can deliver the engineering know-how, the manufacturing experience, thoroughness of testing, and dedicated support that your project requires. Contact a Max application engineer to discuss your most difficult project. Put us to the test. Max. Systems that work.